We've looked at how to solve quadratics using completing the square. It's a tedious process and has a lot of places where you could make errors. So what happens is there's a formula that we can get from completing the square. It's called the quadratic formula. So before we get into that, I just want to remind you how we simplify expressions with roots in them. So here, if we have this expression, remember that our plus or minus is meaning two different things. So this is really standing for 8 plus root 4 and 8 minus root 4. So here, we can just write the plus or minus, or you can split it into those two options. Both are fine. However, the square root of 4, we can break down to be 2 and 2. Because it's a square root, meaning there's no index here, so it's an unsaid 2, that means we need groups of 2. So I have a 2 that can come out of the root, and then I have nothing left underneath. So this will turn into 8 plus 2 and 8 minus 2, or you could write it as 8 plus or minus 2. So if you're choosing to write it like this, then you want to think of this part right here and break it into two separate problems. That it means 8 plus 2 and 8 minus 2. So 8 plus 2 gives us 10, and 8 minus 2 gives us 6. Try this one on your own. Pause the video, and then when you are done, unpause. Okay, so you should have this one broken down. So this breaks down to 9 and 2, and 9 is 3 and 3. So because it's a square root, we have a group of 2. So the 3 comes out, the 2 stays underneath, and we still have that plus or minus in front of it, and we still have that 6. So this represents two answers, 6 plus 3 root 2, and it's also 6 minus 3 root 2. Again, you can choose to write it as plus or minus, as long as you're remembering that means two things. Now let's get slightly more complicated, where we have the root and a number, but we also have it divided by something. So here I'm going to focus on the top first. So I'm going to think, okay, well, 16 is really 4 and 4. So again, we're with square roots, so I have a pair of 4s that can come out. So the 6 and the plus or minus stay. The pair of 4s comes out of the root. I have nothing left underneath the root, so I don't need to write it anymore, and then over 2. Again, this represents two problems, 6 plus 4 divided by 2 and 6 minus 4 divided by 2. Okay? So if I simplify each of these individually, we get 6 plus 4 is 10, and then that's 10 over 2, and 6 minus 4 is 2. So now 10 over 2 simplifies to 5, and 2 over 2 simplifies to 1. So we end up with those two answers simplifying that expression. If we look at this next one, try this one on your own, see what you can get, and we'll come back together and take a look at it. So pause the video, try it, see what you get. Okay, so you should have it broken down. So we've got 4 and 12. 12 is 4 and 3, so I have a pair of 4s. And then a loner 3. So the negative 8 plus or minus stays. The 4 comes out of the root, but then the root 3 has to stay because it doesn't have a pair. And then over 4. Okay. Again, this is really two separate problems. Negative 8 plus 4 root 3 over 4, and negative 8 minus 4 root 3 over 4. Okay. So when we're looking at these, we can't simplify this anymore because this one has a root and this one doesn't have a root. However, I do see that all of these have a common factor of 4. So remember that our variable, or our root, acts much like a variable. So that's why I'm not worrying about what's underneath the root to simplify with the number that's on the bottom. So I'm looking at the things outside the root and seeing if they have a common factor. So since 4, 8, and 4 have a common factor of 4, I'm going to divide each one of those by 4. So if I divide each one of those by 4, I get negative 2 plus 1 root 3 over 1, and then negative 8, no, not negative 8, forgot to divide by 4, and then negative 2 minus 1 root 3 over 1. Now, anything over 1 is just really itself, so this is really negative 2 plus root 3, you can drop that 1, or you can keep it if you need to, negative 2 minus root 3. So we could write this as negative 2 plus or minus root 3. Okay. So I would have anticipated that you made it to here, and then I'm adding this extra bit of information that if these have a common factor, that you reduce it by that common factor. Okay. So here's what our quadratic formula is. It uses the completing the square process, but just completing the square with ax squared plus bx plus c. And what happens is you end up with this thing as your answer. Okay? So it shortcuts the process of completing the square. There is a way to remember this. You can use the Pop Goes the Weasel song. You can use this QR code and see how it's sung. But it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So when you are solving with the quadratic formula, it has to be set equal to 0. So we have both our factoring and our quadratic formula that have to be set equal to 0. Okay? And then remember that a is the thing with the x squared, b is with the x, and c is the thing by itself with no variable. Okay? And remember your a, b, and c do not include the x's. Now we have this thing that's underneath the root, the b squared minus 4ac. We call that thing the discriminant. The thing that's nice about the discriminant is it tells us what kinds of answers we're going to have and how many of them. So if we get the thing underneath the root is greater than 0, that means there's 2 real solutions. If we get that it's less than 0, that means that there's 2 imaginary solutions, because that means we have the square root of some negative number. And remember, the square root of a negative number really turns into our I. So that's how we know that we get 2 imaginary solutions. And then remember, in the quadratic formula, it's got that plus or minus, so it has both of those options. So that's why we know it's got 2 of those imaginary solutions. Same thing here, it just will be a positive thing underneath, but it still has those 2 solutions because you've got that plus or minus the square root. And then if it's equal to 0, we end up with 1 real solution. That's because it would be plus or minus the square root of 0, but plus or minus the square root of 0 is just plus or minus 0, and then when I add or subtract nothing, it gives me the same thing. So it goes from 2 solutions down to 1 solution. So graphically, this is what your options will look like. So here we have a quadratic, and it has 2 x-intercepts, or 2 solutions, 2 roots, 2 zeros. Okay? Now, on this one, we don't have any x-intercepts, but we still have 2 solutions. They're just imaginary. Okay? So when you have imaginary solutions, you know that the quadratic doesn't cross the x-axis. And then we have our third option that goes with our discriminant being 0, in that it just is 1 solution. So what happens is that the vertex is on the axis. Okay? So we're first going to start by figuring out the quadratic formula and saying the solutions based on the discriminant. Okay? So it's helpful to identify your a, b, and c. So a here is 3, b is 16, and c is 5. Remember, your a, b, and c do not include the x values. Okay? So then our formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm going to plug everything in. So we get x equals negative b, so b is 16, so negative 16 plus or minus the square root of b squared, which is 16 squared, minus 4 times a, which is 3, times c, which is 5, all over 2 times a, which is 3. So if we color coordinate, we've got our a's here, we have our b's here, and then we have our c here. Okay. So now what I like to do is I like to simplify the thing underneath the square root. So I like to find the discriminant. So here I'm going to use my calculator. So I can do 16 squared minus 4 times 3 times by 5. So I get 196. So this thing underneath equals 196. So now, because we know the discriminant is 196, that's greater than 0, so that means, if we go back and look, there's going to be 2 real solutions. So I'm going to have where it crosses twice. It may be opening down, it may be opening up. We can check and see real quickly, because remember, our a value tells us if it's opening up or down. So I now know that it's going to have some kind of shape like this. It could be in various places, but I know it's opening up and it's going to touch the x-axis twice. Okay. So now I have x equals negative 16 plus or minus the square root of 196 over, and then I'm going to simplify the 2 times 3, which is 6. Now I'm going to check and see if 196 is a perfect square. So I'm going to do second square root, second answer, and it gives me 14. So it is a perfect square. Or you could break down your number. If the answer you get here is a decimal, then that means it's not a perfect square, and you have to break down your numbers in your root like we did with these problems up here to find the pairs that can come out. Okay? So this is now negative 16 plus or minus 14 over 6. So again, this represents two problems. Negative 16 plus 14 over 6, and then negative 16 minus 14 over 6. Okay? Negative 6 plus 14 is negative 2 over 6, can reduce to negative 1/3. Negative 16 minus 14, you are in debt $16, you go in debt 14 more, that means that you're in debt $30. You divide by 6, which gives us a negative 5. So these are my two answers. Okay. This also means that this is factorable when I get two rational solutions. So rational means that there's not a square root that can't be simplified. So I also could have factored this to find the answer, except for the fact that the instructions say to use the quadratic formula. If it just said to solve and I could pick, I personally would choose factoring because it's faster than the quadratic formula. Okay. So then we're going to look here. We have A, B, and C. So we're going to have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have x equals negative 4, since our b is already negative, plus or minus the square root of b squared, so b is negative 4, minus 4ac, so 2 times negative 3, all over 2a, so a is 2. Okay. So I can use my calculator again to look at the discriminant. What's that going to be? So in the calculator, make sure you put this in parentheses, your negative 4. If you drop the parentheses, it's going to give you the wrong answer because you told it to do the wrong thing. So 4 times 2 times by negative 3, and that gives us 40. Okay. So now that I know that my discriminant is 40, that means that I'm going to have two real solutions. Okay. We can simplify this negative 4 to be a positive 4, plus or minus the square root of 40 over 2 times 2, which is 4. Well, 40, if we try to see if it's a perfect square, it's not. So what I need to do is break it down. Well, 40 is 4 and 10. 10 is 2 and 5, 4 is 2 and 2, so I have a pair of 2's and then a loner 2 and 5. So I get 4 plus or minus, the pair of 2's comes out, and then underneath we still have the 2 times the 5, and then over 2. Oh, I made an error. 2 times 2 is 4. So let's put this 2 here, and then we'll simplify that one to 4. Sorry. Make sure you fix that, because 2 times 2 is really 4. I had dropped that 2, so we're at 4. Okay. So then this is really 4 plus or minus 2 root 10 over 4. I'm going to look outside of the root and see if any of those have a common factor. So 4, 2, and 4 have a common factor of 2. 2 goes into 4 twice, 2 goes into 2 once, so I can choose to write that 1 or not. Keep the root exactly as it is, it's acting like a variable, and then 2 goes into 4 twice. So then I get x is 2 plus or minus root 10 over 2. Now, this answer here is what we call irrational. Remember, your irrational numbers are numbers that have a root in it that can't be simplified. If you look at the square root of 10, numerically, the decimal approximation, it's a decimal that's not repeating and not ending. So that's irrational. Okay. So if I had tried to factor this one, I could not factor this one. So I would have to choose something other than factoring to solve. In this case, you could use completing the square or the quadratic formula. Okay. So let's take a look at this one. Okay. Now, notice, I should have done one that wasn't set equal to 0. Notice on all of these, they were already set equal to 0. So if we had a problem like m squared plus 5m equals 6, it's not set equal to 0. So I first have to set it equal to 0. So I would set it equal to 0 by subtracting 6. So you have to make sure for quadratic formula that it's set equal to 0. So for factoring in quadratic formula, it has to be set equal to 0. For the square root property and for completing the square, it doesn't have to, but it can be set equal to 0. So here, we're going to say A is an unsaid 1, B is 5, and C is -6. So we do x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to do x equals -5 plus or minus the square root of 5 squared minus 4 times 1 times -6 all over 2 times a, which is 1. Okay. So now we're going to simplify. So I can use the 5 squared minus 4 times 1 times -6, which gives us 49. So our discriminant here is 49. Which means that it's greater than 0. So there's going to be 2 real solutions. So we're going to have -5 plus or minus the square root of 49 all over 2 times 1, which is 2. So -5 plus or minus 49 is a perfect square. It's 7 all over 2. So then we're going to have -5 plus 7 cut in half and -5 minus 7 cut in half. So -5 plus 7 is 2. So 2 halves is 1. -5 minus 7 is -12 halves, which gives us -6. So these are rational answers, which means that this could have been factored. Okay? Except for the instructions told us to use the quadratic formula. Okay? So let's find the discriminant on these 3, and then we'll solve one of the other ones. So if we're looking at our discriminant is just b squared minus 4ac. So our b is -2 squared minus 4 times 1 times -2. -2 squared would be 4, minus 4 times 1 is 4, times by a -2 gives us a -8, so minus a -8 turns it into plus. Or you could have done 4 times 1 times 2 is 8, and then negative times negative is positive, so then you get 4 plus 8, which gives us 12. So because our discriminant is greater than 0, we have 2 real solutions. And we're going to pause there and just look at the discriminant. So here, see if you can find your discriminant. So pause the video, find your discriminant, see if you're right. Okay, so you should have found the discriminant. So you've got b squared minus 4ac. So our b is -2 squared minus 4 times a, which is 8, times c, which is -7. So then we get 4 minus, we're going to do 4 times 8 times -7. So if we do 4 times 8 times -7, that gives us -224. So minus a -224, which gives us a plus, which gives us 228. Okay. So here, our discriminant, we would have 2 real solutions since this one is greater than 0. Okay. Here we have -1 squared minus 4 times -3 times by a -3. So we get -1 squared is 1. Negative times negative times negative is negative. 4 times 3 is 12. 12 times 3 is 36. So minus 36. So then here, this would give us -35. So since this is lower than 0, there are 2 imaginary solutions. Okay, so let's take a look at this one with the whole quadratic formula. So we're going to do x equals -b, so -1 plus or minus the square root of b squared minus 4ac which is this whole part right here. And then all over to a, so a is -3. So -1 turns to +1, plus or minus, and we know that this is -35 over 2 times -3, which is -6. So this turns into 1 plus or minus I root 35. I came from the square root of -1, and then all over -6. 35 is 7 and 5. Those are both prime numbers, so I can't break it down and pull anything out. I can leave my answer just like this. I could also choose to put this negative to the top. So it would be a -1, and then this plus would turn to a minus, this minus would turn to a plus, so it's still plus or minus I root 35 and then over +6. So you could have either of these as your answer. And that's how you solve with the quadratic formula.